Hi everyone, this is Mr. Cheng, and in this video we're going to take a look at nested loops, and specifically we'll look at nested for loops. Previously we created for loops that counted up and down, and in this lesson we'll look at loops within loops, also known as nested loops. Now you can nest any kind of loop, including while loops and repeat until loops. Now the reason you'd want to use nested loops is because sometimes it'll be convenient to loop another segment of code that is within an existing loop. So for example, let's say you had one row of blocks, but want the entire grid. Rather than repeat the loop code again and again, you could use another loop to repeat the loop code. Now let's look at an example of nested loops. Now, because we have two for loops, we're also going to have two step variables, and we'll use I and j in our examples. So for example, here we've got the for I equal 1, 3. That's going to loop 3 times. The second loop that we have is for j equal 1, 4, and that's going to iterate 4 times. Now the outer loop here is the loop with the I stepper variable, and the inner loop is the for loop with the j stepper variable. Now after the initial outer loop iterates, the inner loop will iterate until it's finished. Then the second loop will iterate, and again, the inner loop will iterate until it's finished. And lastly, the third outer loop will iterate, and again, the inner loop will iterate until it's finished. Now let's think about the output here before we run our code, and let's try to trace it through. So initially, again, we go I is equal to 1, and then j goes to 1. Again, I stays the same because the inner loop is looping through, so now j is 2. I is, again, staying the same, and j is 3. And again, I is staying the same, and now j is 4. So that's the end of the first iteration. Now let's trace through what happens with the subsequent iterations. So again, we have I goes to 2, j is 1. I is 2 again, j is 2. I is 2 again, j is 3. I is 2 again, and j is 4. All right, let's go through the last iteration here. So the outer loop here, again, it's now gone up by 1. So that's 3. J becomes 1. I is 3 again. J becomes 2. I is 3 again. J becomes 3. And then I is 3. And then j is 4. And now finally, we've made it through all of the iterations with our nested for loop. Now, let's go ahead and test this out here inside of our Roblox studio. So I'm just going to go ahead and add a script here. And let's go ahead and test this out. So we've got for I equal 1, 3, do. Then we've got for j equal 1 to 4, do. And we'll print out the values of I and j so we can see this for ourselves. And we have j here. So let's take a look at this in our output window down here. Make this like a little bit bigger so we can see this. All right, so we have I is equal to 1, j is equal to 1. We have I is equal to 1, j is equal to 2. We have I is equal to 1, j is equal to 3. I is equal to 1, and j is equal to 4. And that's the end of the first outer loop iteration. Then we have 2, 2 and 1, 2 and 2, 2 and 3, and then 2 and 4. And again, the second outer loop iteration finishes. So now we're on the third. So now we have 3, and then 1, and then 3, and then 2, and then 3, and then 3, and then 3, and then 4. All right, now let's think about this. How many times will these loops iterate in total? So again, we have 3 on the outer and 4 on the inner. So in total, let's use an accumulator variable to figure this out here. So we have a new variable role called an accumulator, which keeps a running total. Now the pattern for an accumulator variable is that we're going to initialize the accumulator variable, typically to 0. Then we're going to accumulate, and we'll do this inside of the loops. And then lastly, we'll print. So let's go ahead and add some code here to our nested loops here, and we'll create a variable called count. And then within the loop, again, we're going to increment this. So it's kind of like a stepper variable because we're not doing anything very complicated. We're just adding one at every iteration. So we've got total, and then we've got count. So this is going to increment every time it gets to this part of the code. So it's going to total up the total number of iterations for our code here. So let's give this a try. And as we can see at the very bottom, we have total of 12. Now, another way to figure this out is we can actually just multiply. And we can multiply the number of times the outer loop iterates times the number of times the inner loop iterates. So again, we've got 3 for the outside, and then we've got 4 for the inside. So 3 times 4, again, is 12, is the answer that we got. Now, let's go ahead and add some code here so we can make our grid. So let's add some variables to represent our starting location of XYZ. So let's go local position X equal to 10. We've got local position Y is equal to 0.5. And we've got local position Z is equal to 10. So those are our starting XYZ values. Now let's make a 10 by 10 grid. So to do that, again, I'm going to create our stepper variable. So we've got 1, 10 we're going to do. Now we're going to create another one. Let's create a j variable here. So we have j equal 1 and 10. And then we're going to do, so this is going to create our 10 by 10 grid here. And then let's go ahead and code this. So we've got local part equal instance new part. So we're going to create a part every single time. And let's go ahead and create our part name, and we'll call it board part. And again, let's go ahead and use our stepper variable, our accumulator variable, that's going to accumulate and keep track of like the numbers as we did in the previous one. So let's call this like part num equal 1. Then here, let's add some code here. So we have toString part num. That way each part will have a unique name. So let's have our shape here, and we have our shape of part type of a block. Let's make our brick color random to have some fun here. And then we'll have our material. We'll make that smooth plastic. And then we'll have our position. And this is where we're going to use our position X, Y, and position Z. Go ahead and anchor it. And let's make the size here. We'll make it 4, 1, and then 4. And last but not least, let's parent our parts to the workspace. All right, now we do need to change at every iteration here. We do need to change the X value. So let's change the X value here to X plus 4. All right, so let's give this a try. We do need one more line of code. We do need to increase part num by 1 so that, again, we have unique part names. All right, so let's give this a try. Let's see what it created so far. Now, so far we have all of our blocks, but we didn't create a grid here. We actually created, if we look over here in workspace, we created 100 parts, but they're all going in a row. And that's because we do need to change the Z value. Okay, so outside of the loop, let's again reset our X value to 10. Now let's change our Z value. So now we've got our Z value plus 4. All right, and now let's try this again here. So again, at the end of the inner iteration, we're going to reset our X, and then we're going to increment our Z. Oops. And let's see if we get our grid now. All right, so now if we take a look at our game, we now have our 10 by 10 grid like so. All right, so the important part here was we need to, at the end of the inner loop here, we had to reset our X. And then again, we are now changing our Z value at the end of every inner loop. And that way it kind of goes into strips like this going across, versus if we didn't increment them, we had 100 parts going straight down. All right, I hope that helps, and I'll see you in the next video.